Today we're going to look at quadratic functions and transformations. This is section 4-1 in your book, covering Common Core benchmarks FIF 2.4, 2.6, 3.7, 3.9, and FBF 2.3. The objective is that you will be able to graph and label quadratic functions with a table and transformations. Some important formulas that you need. The vertex form of a quadratic is y equals a parentheses x minus h squared plus k. When we looked at absolute values, you've already seen h and k as transformations, and should remember that h and k make your vertex, h as opposite and k as is. Instead of becoming the vertex of the absolute value, this becomes the vertex of the parabola. And then your axis of symmetry is x equals h. It always goes through the x value of the vertex straight down the middle of the parabola. This is what the graph would look like. For a standard quadratic, your vertex is going to be at 0, 0. Some other points that we look at is 1, 1 and 2, 4. And then because your quadratic or your parabola has an axis of symmetry down the center of the vertex, these points also get reflected to -1, 1 and -2, 4. So let's look at how to graph a quadratic. First, we're going to look at some vertical translations. Remember that a plus k is going to translate up k units, and a minus k is going to translate down k units. So let's graph the function y equals x squared minus 5. First, we're going to start by identifying the vertex. The vertex of this one is going to be the point 0, -5. Then next we're going to identify the axis of symmetry. The axis of symmetry here is going to be x equals 0. Next, we're going to make a table of values. So we do our table, and it's going to get centered around the vertex. So what we do is we put the vertex in the middle, 0, -5. Pick two numbers less than 0 and two numbers greater than 0. This will give us a good idea for the table to graph. So we plug into our equation back up here, x squared minus 5. So what we'll get is -2 squared minus 5. And that's going to equal 1, because -2 squared will be 4, and then 4 minus 5 is 1. Then we do -1 squared minus 5, which will equal -4, because -1 squared is 1, 1 minus 5 is -4. Now because this is a vertex and also your axis of symmetry, everything that you do on the left-hand side will reflect to the right-hand side. So a positive 1 will end up with the same answer as the -1, which was -4. And a positive 2 will end up with the same answer as the -2, which is a 1. The fourth thing we're going to do is now graph our table that we've created. So we start with our vertex, which was step 1, which is 0, -5. Through that, we have our axis of symmetry, which we draw as a dashed line. And then we plot the points we found in our table, which was -2, 1, and its reflection, 2, 1. And then -1, -4. Oh, let's put the vertex in the right place first. So let's erase that, and that's actually going to go down here. And so -1, -4, which we reflect over the axis of symmetry. To the other side, 1, -4. And then instead of drawing straight lines through your points, you want to draw a curved U shape called a parabola. There's one in the book for you to try, and you can look the answer up in the back of the book. Look at page 196, got it, 2A. Try it on your paper, and then look the answer up in the back of the book to see if you understand. Write down any questions that you may have if you get it incorrect. Now let's look at horizontal translations. Again, from absolute values, we learned that a negative h translates us right h units, which is the opposite, and a positive h translates us left h units. So let's graph this function, y equals x minus 4. Same as the previous page, we're going to go through the same steps. First, we're going to identify the vertex. This time, the vertex is going to be 4, comma 0. So this is your h value, and remember that your vertex comes in the form h, comma k. H is always as opposite, so the negative 4 becomes a positive 4. K is as is. Since there's nothing outside, then it is 0. Our axis of symmetry on this one is going to be x equals negative 4. And now let's make our table. And again, you want to put your vertex in the middle of the table, not negative 4, positive 4, to match your vertex. Positive 4 here, positive 4 here. So we're going to put our vertex in the middle of the table, which is 4, 0. We're going to pick two numbers less than 4, which is 3 and 2, and two numbers greater than 4, which is 5 and 6. Remember that your vertex is a reflection point, so you only need to do two of the numbers, and then they will reflect to the other side. So let's do 3. We're going to plug into the formula x minus 4 squared. So we're going to do parentheses 3 minus 4 squared. 3 minus 4 is negative 1. Negative 1 squared is 1. Then we plug in 2 minus 4 squared. And this time we get 2 minus 4 is negative 2. Negative 2 squared is 4. And these will reflect, so the 5 matches with the 3, which is 1, and the 6 matches with the 2, which is 4. So on either side of the vertex, the first number has a value of 1, and the first number on the other side has a value of 1. The second number up top has a 4, and then the second number after also has a 4. Now let's graph. So again, we start with our vertex, which is 4, 0. Notice that we went to the right 4 units. Looking back at the function, a minus 4, which is like a minus h, tells us we will translate right h units. So we went to the right 4 units. That is also our axis of symmetry, so we draw our dotted line through that vertex at x equals 4. And now we graph the numbers in our table, which was 2, 4, and its reflection of 6, 4, and then 3, 1, and its reflection of 5, 1. And again, it's a U-shaped graph to create your parabola. So make sure that you curve it, especially down at the vertex. You should not be straight lines connecting the dots. Again, here's another problem for you to try on page 196. Got it 2A, and you can look in the back of your book. Now let's look at stretches and compressions. Stretches and compressions come from the value a in front of the x squared. In absolute values, this also acted as your slope. But in quadratics, it cannot be a slope. When a is greater than 1, you still have a stretch, and when a is between 0 and 1, you still have a compression. But if we look at this example to graph y equals 1/2 x squared, we have to follow the same 4 steps we did on the previous 2 slides. We're going to start first by identifying our vertex. Since there's no h value inside and there's no k value on the outside, then our vertex is going to be the basic 0, 0. And so our axis of symmetry is going to be x equals 0. Then we're going to make an xy table. For the xy table, we're going to put 0, 0 in the middle. Now I'm going to pick two numbers less, but since I have to take a half of the number, I'm going to pick even numbers, -2 and -4, and then 2 and 4. And I did even numbers above and below 0. So when I plug in, I will do 1/2 of -4 squared. -4 squared is 16, and 1/2 of 16 is 8. Then I have to do 1/2 of -2 squared. -2 squared is 4, and 1/2 of 4 is 2. And then they reflect on the other side of the vertex, so 2 matches with -2, giving an answer of 2. And 4 matches with -4, getting an answer of 8. And then our fourth step is to graph it. So our vertex is going to be at 0, 0, with the axis of symmetry running through that. And then this time our numbers are going to be -4 and 8, with a reflection on the other side of 4, 8, and -2, 2, with a reflection on the other side of 2, 2. And then I'm going to graph my parabola through those. And what happens is the parabola has gotten further away from the y-axis and becomes a little bit fatter or compressed. So here's a problem for you to try. On page 195, try Got It number 1A. Again, look the answer up in the back of your book and let me know if you have any questions when you come into class. Alright, so let's look at putting all of it together. Now we're going to look at stretches, compressions, horizontal translations, vertical translations, and there's a negative in there which will reflect the parabola. So we're going to continue to go through the same 4 steps in the previous 3 slides. Let's start first with identifying our vertex. So we use the opposite of the number inside and the number outside as is, making our vertex 1, 3. Then our axis of symmetry is going to be x equals 1 to match our vertex. Now let's make a table. So we're going to make our XY table. In the center, we're going to put our vertex 1, 3. Now let's pick two numbers less than 1, which is 0 and -1, and two numbers greater than 1, which is 2 and 3. Because our vertex also has an axis of symmetry, the same as we've been doing, we're only going to do the two numbers above 1, and the two numbers below 1 will have a same answer. So let's start with 0. We're going to do -2 parentheses 0 minus 1 squared plus 3. Following our order of operations, we're going to start with our parentheses, 0 minus 1, giving us -1. Next comes exponents. We have to do -1 squared to get a +1. After that becomes multiplication. So we take 1 times -2 and get a -2. And then finally we'll add 3 to that and get an answer of 1. We reflect that on the other side so that 2 has the same answer of 1. Now let's plug in our -1. We get -2 parentheses -1 minus 1 squared plus 3. So, again, starting in the parentheses, negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 2 is 8. Negative 8. Negative 8 plus 3 is negative 5. And we reflect that answer to match up with the positive 3, so we have 3, negative 5. Now let's graph. Again, we're going to start with our vertex, so we're going to go to the right 1 and up 3. Through our vertex, we're going to put our axis of symmetry. Now let's graph the other numbers in our table. First one is going to be negative 1, negative 5. And that one has a reflection on the other side of 3, negative 5. Next we go to 0, 1, and it has a reflection on the other side at 2, 1. Notice that this parabola is skinny because it was stretched by a factor of 2, and it's upside down because it reflected over the x-axis. And then the negative 1 told us to go right 1, and the positive 3 told us to go up 3. And that's how we obtained the vertex. That is the end of your lesson. Make sure that you bring in your questions.